Hi, in this video we'll be looking at integrals that involve integration partial fractions. What type of integrals can be broken up into partial fractions? The answer to this question is when the numerator usually is larger than the denominator, or the denominator is simply factorizable. Here we can see that there is this denominator 9x squared minus 4 is difference of two squares. Difference of two squares means that we can factor it into 3x plus 2 and 3x minus 2. So the fact that this denominator can be factorized means that we can break up the numerator into partial fractions. So let's see how it's done. Because at the minute it's not easy to break up 9x squared minus 3x plus 2. These polynomials have the same power, and actually the coefficient is the same as well. So we cannot simply go into partial fractions directly. So the first step in this case is to divide the numerator with the denominator. That's, that's to say, basically perform algebraic division so that we'll have a coefficient, we have a dividend that is simpler to work with. So dividing 9x squared minus 3x plus 2 in British schools we use the Bose-Stop method, and what's on top of the fraction goes on the right hand side, and what's at the bottom of the fraction it goes on the left hand side. So we say because these two the constant is the same as the power of x is the same, we only need a 1 here. We multiply it out, and with this 1 multiplied by these two factors will give us these two. We're going to put a bracket around this, okay? So you see that the negative 3x will come down. 2 minus a minus 4 will give us a plus 6. So I would put actually the minus sign here, and using the bracket, the minus and the minus will give us a plus 4. Then that's it. Remainder is already smaller than the dividend, therefore there is no more division to be done. We can write this fraction as 1 plus the remainder over what we were dividing by. Okay, now this fraction is something that can be broken up into partial fractions. We are going to look at that on the next slide. Okay, so we said we are going to break this fraction into partial fractions. Because I already factorized the denominator for you, we said the denominator can be written as 3x plus 2 and 3x minus 2. Therefore, we are going to write a over 3x plus 2 and b over 3x minus 2. We're going to pretend that we are cross multiplying. At this stage, we know the denominator here is the same as the denominator here. Therefore, this numerator must be the same as this numerator. We can ignore the denominators and just put them aside for now and multiply out the numerator here. On the top, we'll have 3ax minus 2a, and we'll have 3bx. Factorizing the x, we'll have 3a plus 3b, and the constants remain to be positive 2b minus 2a. Now we're going to equate coefficient of x with coefficient of x in the numerator up here, or here, the same thing. The coefficient of x is minus 3, and we have 3a plus 3b. That's one of our simultaneous equations. The constants add up to 6. So 6 is equals to 2 lots of A plus 2 lots of B minus, well, 2 lots of B minus 2 lots of A. We can divide this by 3 with minus 1 equals to A plus B, and we can divide the second equation by 2. 3 will equal to B minus A. Okay, these two equations, we can add them together because the a's will cancel away. This is a plus a, this is a minus a. So adding those two equations with each other will give us a 2 on the left hand side and a 2b on the right hand side and a 2 on the left hand side. B is therefore 1. Substituting back into the first expression there, we have a plus 1 equaling minus 1. A must be a minus 2. We go up here and we write that line with minus 2 over 3x plus 2. Therefore, the final answer, once we figured out a and b, capital A and b, that means that, actually, let's write b first. 1 over 3x minus 2, because it's nicer to have the negative. So that's the answer to this line. Uh, this is a x, not a multiplication sign, and minus 1 minus 2 over 3x plus 2. Okay, so this actually is this line here. Okay, okay, right. So let's look at the integration and how we are going to integrate this. We were going to integrate this fraction. We know now that this fraction can be written as integral of 1, because there was a 1 there, and also adding integral of 1 over 3x minus 2 with respect to the x, and subtracting integral of 2 over 3x plus 2 with respect to x. So we are going to integrate these three terms on the next slide. Okay, as promised. Now we are going to get to integration. Term by term, integral of 1 is simply x. Integral of 2 over 3x plus 2 is going to be a logarithm. Logarithm of 3x plus 2. But a factor of 3 is missing in front of the integral. Therefore, we can factorize this 2 out. We can put a 3 inside the in front on the top and pull a 3 out of the integral as the denominator. Okay, so what happened here was that we put a 3 here and a 1/3 outside the integral. Now the this 3 matches up with what's the derivative of 3x. Therefore we can take out the log. Say the answer is log. These two can simply be pulled out at the front. This 2 doesn't need to be there. So there is a factor of negative 2/3 that multiplies by log of 3x plus 2. And, well, we have put the 2 on top of the log. That's the same thing. Finally, integral of 1 over 3x minus 2 once again is 1/3 at the front log of this expression. Why did we pull a 2 and put it on the power here? Because we can apply the logarithm rules. Here we have a negative and here we have a positive in front of the log. That means that we can we can put this in the denominator, 3x plus 2 to the power of 2 down here, and write it as simply just one log. Okay, let's look at the neater version. This is the final answer, and we have a plus c because this was an indefinite integral. This was the one and only example that should help you solve problems involving partial fractions. I know this was a rather involved example, but I